It's all out of order.
Oh, it's because the
Oh, right. End of the semester, they all get this stuff.
Thank you. Okay, sorry, I'm back. Sequence. The decimal form will be helpful if you think about sequence mode. Yesterday in our calculator, we talked about how we can make the calculator recursively find a sequence, aka jumpity jump, jump, jump to the 100,000. It's just going to take a little while. It's going to be thinking for a little while if you ask for like the 5,000th term. Ethan, hi. So if you're using your calculator and you're trying to look at a sequence and see if it stabilizes, couldn't you find, how would you find in your calculator, using this mode that we talked about yesterday, how would you think about whether or not the sequence is converging? What would you do after you put in, for instance, this example right here?
Yeah.
If you were to use your calculator to think about it, how could you use the calculator to strategize, to experiment, to think about whether the sequence is converging or diverging?
Would it do that thing?
It's converging. No, it's not. I don't know what's going on.
Wait, if it's converging or diverging, wouldn't you have to?
It goes, it's a line, it goes on forever.
Okay, so it looks like it's a line that's going on forever. That's true.
No, it doesn't.
That wouldn't be enough of an explanation to tell me converging or diverging, sadly.
Oh, change the oscillators.
You could change the window and zoom out, zoom out, zoom out, and see that it keeps on increasing and going higher and higher and higher. Couldn't you also go to the table? Didn't we talk about yesterday? Couldn't you make it ask, and couldn't you find the 10th term, 100th term, 1000th term? What are you trying to think about? What's going on as I continually find more and more terms in my sequence? And what are the terms do? Are they getting closer to a number? And how will you know that? How will you see that? Because it should be getting more and more fixed. What does that mean?
So it's single number.
Yeah, if there are decimals, if it's like 0.397 and then 0.526 and then it's 0.7, oh, you guys are back. 0.713 and then 0.7129 and then 0.712999. I don't know, I'm just trying to make up something. Like where it seems like there's some variation and all of a sudden it starts becoming fixed as you get higher and higher terms, well then, yes, it's stabilizing. Does that make sense?
Yeah.
Now, in this one, hold on, there should have been a lot of reasons that you very quickly said this one, if you remembered what this sequence was diverging. Corey, yeah, you're right, it's increasing forever, but why? What's it doing every time recursively? So isn't it going to be ever expanding? 4, 6, 8, 10, 12, it's going to keep on getting bigger and bigger. It's not getting closer and closer, stabilizing towards any single constant. So yes, of course this one is going to be divergent. Wait, what kind of sequence is this?
Arithmetic.
Yeah, arithmetic, however you want to say it. Right? It's a sequence where you're adding a constant. Question. Can we generalize the statement? And we wouldn't say since this one is divergent, but using the similar logic from this one, can we say that all arithmetic ones are divergent?
Yes. I mean,
Why?
it's a simple arithmetic.
Well, but arithmetic by definition, Tom, arithmetic by definition is you're adding a common difference every single time. A constant difference every time, right? So if you're adding the same number over and over and over and over again, how is that ever going to stabilize?
It isn't.
What if you, what if you subtract? What if you add a negative every single time?
It's still
Yeah, it's not going to positive infinity, but it's going to negative infinity. It being the individual terms, right? Talking about sequences. Okay. How about geometric then?
That can have problems.
Give me like a simple example of a geometric that would diverge. A divergent geometric sequence.
You
find something.
A sub 1 equals,
Oh, gosh.
give me something, starting point. 3, and then R equals 4, sure. 3 times 4 is 12, 12 times 4 is 48, 4 times 4 is, what's happening to that sequence?
Bigger and bigger.
The terms are expanding, therefore the sequence is going to diverge. Wait, what if we made it a negative? 3 times a negative 4. Negative 12, positive 48. Oh, it has all sorts of issues. Number one, the signs are bouncing back and forth, and it's, the points would be getting ever increasing, ever more positive, or ever more negative. So when will a geometric converge? Yes, I just said when, because it can. Let's start at 4 though, just to make it easy, but 4 times a half is 2. 2 times a half is 1. 1 times a half is a half times a half is a 4. Isn't that the example of Zeno's paradox? Where you're adding, I shouldn't say that, where every step I'm taking, I took a step of a half, and I took a step of a fourth, and I took a step of another, that'd be now 8, and then 16, and you keep on going. Yes, there are infinite steps, but
Isn't that the,
isn't it stabilizing towards, for this example, wouldn't I be stabilizing towards 0?
isn't this limits?
The idea of limits. Yeah. So, the nice thing is, if we're trying to look at a sequence and ask ourselves whether the sequences are much easier than series. Sequences will cover in like a day or two. Series, it takes us basically another 2 months. Maybe a month. So coming back. Sequences. Convergent and divergent sequences. It's as easy as saying, does the limit exist? Wait, what limit? As you go to infinity. Why not negative infinity? Sequences don't have negative integers. Why?
It's continuously increasing.
No. I'm not saying you can't go towards negative infinity, but I'm saying a limit will only be as n approaches positive infinity. No reason to even consider the limit as n goes to negative infinity because it never can. Why? N represents
It represents a number.
the number of terms. So the first, second, third, do you have a negative 1th term?
No.
No. Same reason that we don't have a 1/2 term, right? First term, second term, third term, n will only ever be going towards positive infinity. Does that kind of make sense? So we're taking a limit as n goes to positive infinity for sequences, not series. Sequences, not series. Sequences, not series. So for sequences, limit as n goes to infinity, does it equal a constant? If so, sweet. If not, divergent. Down here, if a function is bounded and monotonic, monotonic means what again? Doing or going one direction, strictly increasing, strictly decreasing, strictly constant. Then it must converge. Ooh, bounded and monotonic. Bounded and monotonic. So wait, why then doesn't sine or cosine converge? Aren't they bounded between 1 and negative 1?
But they're always increasing.
But they're increasing, decreasing, they're not monotonic. So they're strictly monotonic. Wait, ln is always increasing, then shouldn't he converge? No, because he's not bounded. He goes to negative infinity and positive. Okay, you guys have the information? So then, ready, set. If it's as easy as that, do we even need to write the first 4 terms to figure out whether or not these converge? No. But what would the first 4 terms be? You guys don't have to write the example, but maybe I won't make you write all the.
I know it.
Okay, pause. Good job. Write them down. Go. But yes, I do agree with you on this one. This one is convergent. Since the limit as n goes to infinity of a sub n. Does that make sense?
Yeah.
Okay, keep going. If you're not sure, then write out the first 4 terms. The first one would be 1, 1/2, 1/3, 1/4. And that is a helpful exercise because you're not always given the formula for sequences. Or even when you are, it can be quite confusing. And we did a lot of background to make this page hopefully fairly easy. It does start to get a little exciting.
Is it considered stabilized if it doesn't move at all?
Seems pretty stable to me. Does that make sense?
Yeah, so conversion. Justin Timberlake came out in December. That's nice to know.
That was like 3 days ago.
See, here's the number.
I know,
Yeah, I knew that one. It's inside of the 9, right?
It converges.
Nice job, Corey.
I'm just showing.
I know. I know.
What is?
That's approaching. Oh,
That one's hard.
Doesn't that show?
letter E, we get our first oscillating one.
Can I get a divergent, please?
For 100?
Wait, what's D?
So how do we know if it's divergent?
Converging to 1.
D?
Yeah, the D.
D.
It's converged.
The letter D.
Oh.
That's right?
Well, what's?
Yeah, that's fine.
What?
Right?
Alright,
Can read out.
letter B, what'd you guys get?
Whoever did that.
Converging to 1/2.
Who did that?
Nice.
How about letter C?
Converging to 1.
Yes, to 1.
Because you guys are thinking infinite limits, I should say limits to infinity, or I guess our book would say limits at infinity. You're thinking about degree tests, right?
Diverging for converging.
Converging, since, does the limit exist?
Yeah.
Yeah.
Yes.
4.
Question, would this series of 3 converge or diverge?
Diverge.
Yeah. Series, you replace all the commas by additions. So what would 3 plus 3, then 3 plus 3 plus 3, and then 3 plus 3 plus 3 plus 3? What would this series?
That's a series. You can always
But we're not there yet.
Converging is going towards.
How about this one? The sequence. What's it doing?
It's also
Diverging.
Converging to 0. To 0.
Struggle. Is it oscillating? Yes. But is it oscillating towards a single limiting value? Yes.
0.
Yeah.
So the sign did not mess it up. Now what if it was expanding and oscillating signs or changing signs? That would be divergent. But since it's changing signs and yet still stabilizing, well then we're fine. Limit is 0. How could you do that mathematically? Isn't the negative 1 to the n plus 1 just what flips the signs back and forth, back and forth? Look at the 1 over n. What's the limit? 0. 0 times other signs. Well, it doesn't really matter. Still 0. How about the bottom one?
Yeah.
No, that's. Can you say converging to that?
That's negative 1 and 1.
Whoa.
Struggle.
You just said absolute value.
Wait, I just wanna. Yeah, I'm sorry.
You're so converged feels like backwards.
I don't know if I like the word oscillating, but I can say that. Oscillates between negative 1 and 1, which do not agree, so therefore I would say the limit does not exist. Why? If these were all positive, would it be getting closer and closer and closer to a positive one? Yeah, then it would converge. If they were all negative, would it get closer and closer and closer to a negative one? Yeah, then it would converge. But what's it doing? And if you looked at the graph, wouldn't it be getting closer and closer to positive 1 and negative 1? So yes, it's bounded. Yes, it's bounded, but it's not monotonic. If you want to think about it that way, if you were just looking at the function, and since it's a sequence and it's just like the points, it's not the continuous curve. The points are ever getting closer and closer to both positive and negative 1, but not at the same time, therefore divergent. That was a little weird. E convergent, stabilizing towards 0. They agree from either side, the positives and negatives. F, nope, they disagree. Okay, how about this one? Wait a minute, what's it asking us?
Probably the first 4 terms, then to converge.
Isn't it basically the exact same thing?
Yeah.
Yeah.
So what it's trying to say is if the sequence is converging to a single limit, as that should be an n approaches infinity, then we can say that the entire sequence will converge. Let's just go through and do it quick. I'm not going to write it all out. But what can we say then about A, convergent or divergent? Convergent because the sequence is approaching
0.
How about letter B?
Convergent.
Converging because the limit would be.
-7.
How about C?
Zero.
Converging, you might not see it, it's an n cubed over an n to the fourth, so therefore yes, it would go to 0. How about D?
Diverge.
Why diverge?
It goes to infinity.
Top wins, so therefore it's going to infinity. Which infinity? If n is approaching positive infinity. Positive over a positive is a positive, if we had to defend ourselves. How about letter E?
Bottom wins, so it converges to 0.
How does the bottom win?
Because it's in the top.
It's an exponential, which is much faster than a polynomial. How could you tell me and prove that to me mathematically? Or
Make a table.
no, plugging in numbers doesn't prove. Making a table doesn't prove. It'll illustrate, doesn't prove. Why would you be deriving a limit? L'Hopital's. Have we done L'Hopital's this year?
No.
Yeah, section 2 is L'Hopital's.
Maybe you cheated and used it, but we haven't actually covered it. Why? Because it's section 9.2.
Oh, and we had definition.
Woo!
That's the hospital!
Ready, set, endeavor card.
Oh, dang it, no.
Ready, set, endeavor card. What are we on, 10?
I worked so hard to squeeze.
Oh, we have to go to 11.
11?
Oh,
You guys just quoted them how many times?
know.
Yeah, this is 10.
Is this the first one? That's 10, it's 10, yeah.
I thought it was 10. Endeavor number 10.
see? I got you. I really
Kyle, write them down. Endeavor number 10. You're okay, others were talking, I was just trying to get us all facing the direction. Does it make sense that ln of n over n, the limit as n goes to infinity would be 0?
Yes.
Yeah, bottom wins, right? ln's not very strong. How could you do that? L'Hopital's. Be 1 over n, all over 1.
Is that x to the 1 over?
X to the 1 over n. For all x greater than 0, we can say this. If x is negative, we'd have some issues. But for all positive x's to the 1 over n, well, 1 over infinity would be 0, anything to the 0 is 1, that makes sense. Careful. I can make quite a few things make sense that are wrong. Ooh. Life lesson for college? Just saying.
The third one is
College.
like forever.
You mean COC?
Right, like because you put that in like.
Yeah, I snuck this one in at the beginning of your forevers last year, but we never really used it much.
Misty, I have a question. So sometimes in the AP during FRQs, you get points for justifying your answer. Let's say that the answer you came up with is wrong, and your justification, even though you
I'll
have
give you a justification point if you state it wrong.
Because I know for
It depends, it depends on the topic.
okay.
Like, for instance, if you were to give the wrong absolute max, but you said something to the effect of, this is true because when testing the critical numbers and the endpoints, this was the highest, and you were, like, your math was wrong, they would take off for the wrong math, but they would give you for testing.
Thank you.
What are we doing?
Alright, kiddos, there's so much talking, I am so distracted, I couldn't even answer Gabby's question. So even though you can multitask, that's not normal, and to be honest, it's not very helpful for problem solving, or for using your brain properly, for being able to focus at a task at hand. Some people are like, oh, it's so great, this generation can multitask, yeah, but they can't really focus on one thing at once. That's dangerous.
Like
Tom.
texting and driving.
What is the last one?
The last one is x to the n over n factorial.
Have you ever texted and tried?
Why is it important that we state that one? You can't derive a factorial.
True.
But if you were to go into sequence, not even sequence mode, a function, if you were to plug in higher and higher and higher n values, x values, does that stabilize to 0? It converges. It gets closer and closer and closer to 0, which tells us, wait a minute, well that's just a polynomial. Okay, no big deal. A lot of things beat a polynomial, right? People with calculators. Try something exponential over something factorial. Isn't exponential the highest or the fastest growth that we've seen thus far? Don't exponentials beat polynomials, like this one? Oh, that's not a good one. Where did oh, we had an example of it a second ago.
Factorial. And what do you want us to raise it by?
No, x factorial.
Well, x factorial.
So do Oh, this is, okay, that's not a polynomial, sorry, I was thinking x is going to infinity. That is exponential. Plug it in, do 2 to the n, or do 10 to the n, or even do 100 to the n, all over n factorial. So 100 to the x over x factorial, 50 to the x over x factorial, 2 to the x over x factorial. And I want you guys to go ahead, and I guess you could look at the graph, but it might be a little bit nicer if you go to a table and plug in 10, plug in 100, plug in 1,000. Who wins? Exponential, that guy that's been super fast and the strongest thus far, who always won in L'Hopital's? Or factorial?
Exponential.
Yeah.
On the last one in the bottom right, is that an n?
X to the n, yeah. All over n factorial.
Oh.
At first,
Did you remember how to find a factorial? Where is it in your calculator?
Second.
Yeah, you go math and then you go over, right?
At first, exponent, what is it, the top? But then, yeah.
The graph's gonna be really weird and funky. It's gonna be oscillating there for a bit. Well, depends on what you choose. It might be increasing for quite a while and then it starts decreasing. So that's why I said go to the table, and go to table ask, and then plug in when x is 10, when x is 100, when x is 1,000. You can do like 2 to the x over x factorial, or 10 to the x over x factorial. I don't know.
It's probably because it's too big.
Yeah, if you only have going by 10. Have you tried Zoom Fit yet? Like,
The numbers are
Yeah,
too big to show on there.
what'd you put?
My bounds are
50 to the x.
6,000.
Well, if it's 50 to the x over x factorial, if x is 1, that's 50. So you need to have your window be
No, yeah, my y is 1,000. 6,000.
Yeah, it goes to error.
That's weird though, that's not even showing up on.
No, it says error on base because it goes faster.
Do you need to insert parentheses around factorial?
Since when do I have to come to
I don't know either, but- Well, the 50 squared, hold on, 50 squared would be 2,500. I know, we went to 6,000. You should go see it. When you went to your tables, that's all you need to know. Hey guys, who wins? Factorial. So who's the fastest growth out of all elementary functions? Exponential functions. Well, I guess exponential or transcendental. But who wins from all the basic functions that we covered from all of last year? Exponential, but who truly wins as far as functions that we could use? Factorial. Factorial is the fastest growth, and that's what this last one shows. So this one is an important one as far as factorial being the strongest type of growth, and factorials are going to come up a lot in sequences and series. This one is pretty important in that exponential will always approach 0 whenever I have bases in between 1 and -1. So when I have 1/2 raised to any power, or 1/3 to the n or to the x, that one's pretty important. The nth root, we'll get back to that one a little bit. He's fairly important. This one with e is also fairly important. You guys have seen him before. This one you can figure out on your own. This one you can figure out on your own. I think this one, not so sure you could figure out that infinity to the 1 over infinity is 1. That seems a little iffy, but anyway, we'll get back to that as we need it. So, endeavor number 10. What can we do then? What can we do then when we see ln of n squared over n? It's not exactly like the forever card. What can we do?
And strong.
Yeah, we could go ahead and bring the 2 down, and then we could go ahead and say, oh, ln of n over n, who wins?
And
0.
Or like ln.
Bottom wins, right?
yeah.
So even though the 2 came down, did the squared actually really result in any change? The answer is no. Okay, how about letter B? You have the endeavor written down.
Technically, it's 2 over n, well, n to the power of 2 over n.
We could rewrite this to be n to the 2 over n. How do we use the endeavor though, or how do we use?
2.
What's the limit as n goes to infinity of n to the 1 over n?
1.
So it's what 2.
Oh, it's not gonna be 2.
1/2.
It's not gonna be 1/2.
Squared, so it's 1.
Wouldn't I pull the 2 out because of power to a power you multiply?
Yeah.
I can make this 2 times 1 over n, or think of it this way, couldn't I make this the nth root of n squared?
Yeah.
Okay, so what's the limit as n goes to infinity of that? 1. And what's 1 squared?
Whoa.
Let's get there faster.
Math.
Right?
Uh-huh.
Okay, how about letter C?
3 over.
3n to the.
So that's 3 and
1 over n.
So it's basically,
Still 1.
We'll still get there.
no, yeah,
Three.
I think it would still be, it's either 1 or 3.
Uh-huh.
In the 2.
I know, but we're not in the guessing game, we're in the solving game. Come on, guys, stop guessing and let me know how to rewrite it. No, what do you see?
Well, first you could rewrite it as a exponential.
Oh, you wanna do that first?
To the 1 over n.
And you can split that over to
Oh, you split them.
3 to the 1 over n
You just turn
times n to the 1 over n.
Okay, just turn
And
it
that's
to
n times, what is it, 3 to whatever that is, approaching 1 anyways. Whatever number you put in to get smaller.
It says x to the n approaches 0.
So it's 1, so 1 times 1 is 1.
yeah.
Oh. X to the n, is that x to the n, x to the n?
But I have 1 over n, can I still use that?
Whoa.
That's
That's the x to the 1 over n.
Oh, it's 1.
Oh, x to the 1 over n, I thought I said, I heard x to the n. It's x to the 1 over n, yeah?
Yeah, that's 1.
Yeah.
So you're saying this approaches 1, and how about n to the 1 over n?
1 approaches 1. It's 1.
It is, but there's another property. Brendan, look at, what are you guys looking at?
Oh, I see. Look at the second.
X to the 1 over n.
Oh!
Now pause and think about it. If we were gonna do our trick, which is our really fuzzy math, which you have to be careful of, from last year and plug in infinity, what's gonna happen to this 1 over n as n goes to infinity? It's gonna approach 0. So if I have 3 to the, well, ever smaller exponents, yeah, it's gonna approach 3 to the 0, and 3 to the 0 is 1. That's the way that I was thinking that you guys could actually think it out, as far as why the answer is what it is. But be careful, because just because something makes sense in your head, once again, does not necessarily mean it can be proven to be true. How about letter D?
0.
Yeah. What are you using though?
No, x to the n.
Oh.
Between -1
X to the n when I have smaller values of, guys, it only makes sense, right? If you were to expand it out, wouldn't the first one be -1/2, then +1/4, and then -1/8, and then +1/16?
Yes.
Even though positive, negative, it's still stabilizing to 0. Good. How about letter E?
0.
0.
Stop guessing and tell me how to rewrite it.
No, it's not so.
You can,
Oh, you can. I think it's split them.
art method.
You can't split them apart, so you can make it 1 minus 2 over n to the n, you mean?
Yeah.
Who is this? E?
To the x.
Negative x.
To
There is no x in here.
e to x. It's 2.
There is no x.
E to the
E
x.
2.
I know, it's okay, you gotta get used to the formula, it's b squared, yeah?
It is a variable. If it's even,
0.
if it's still
Hold on.
subtracting, does the rule still work? Because this has plus. Will we eat addition?
Yeah,
Yeah, would it be negative?
since x is negative.
Or no?
Because you could make this plus a negative.
Yeah.
Oh.
It'll be evenly.
So can we just put triple plus or minus on
Nice job,
To be
Reese.
honest, off the top of my head, I didn't know the formula, I knew it was 1 and then x over n. It's plus, yeah, not minus.
Yeah.
So we could change the subtraction to addition of a negative. Guys, careful.
Oh.
1 over
We started with 0, which was wrong, went to 1, which was wrong, went to e, which was wrong, went to e squared, which was wrong, we finally got to e to the negative 2. Careful.
Yeah.
How about letter F?
0.
0.
But it's 100 to the, no, who wins?
It don't matter.
To the bottom.
Does he win immediately or does it take a while?
Takes
It takes a while. Hey, there's a life lesson in that too, but anyway.
It's just fun.
Tortoise in the hair, we could go there. Anyway, homework number 33, section 9.1 is due tomorrow. Question though, how would you guys go about this guy?
The bottom one still.
What?
Well,
Sign's oscillating.
Yeah.
Oh.
Sine squared?
Well, sin squared only goes in between one. That's cosine squared plus 1 minus 1. That's still oscillating.
Wait, what does sine squared look like?
But it's not oscillating between 1 and -1.
Well, it's still not oscillating. Either way, it's not oscillating 2 to the n.
Either way, sine is still bounded, true?
Yeah.
How about 2 to the n?
No.
It's not bounded.
Infinite. So who's gonna win?
The bottom, so it's 0.
Sine squared then?
That's sin squared over x equals bounce from 1 to 1.
Sine squared?
No, sin x over x.
Oh, right. But then this would be 2 to the n, so we're applying.
Cosine squared plus 1 over x is 0.
Cosine squared?
Or cosine plus 1.
Question. Could we have proven this with L'Hopital?
Yes. Yeah. No.
Because what's gonna happen as you keep on taking derivatives of trig?
Oh, it'll just loop. It's just gonna keep, it's gonna go back between sine and cosine.
It's gonna go back and forth between sine and cosine. So that's not gonna work. So how can we prove it? Nah, that's just gonna illustrate it. How do we prove it? And no, I'm not even going into like the deep college definition of a formal proof, just an informal proof. Squeeze theorem.
Oh.
Because, what do we know about sine squared? Sine squared. We said he's bounded. Now he's not bounded between -1 and 1 because it's squared.
1 and 1.
1 and 1. No, he's not. He goes. You can't say he's bounded between 1 and 1. Sine squared is not always 1. 0 and 1. That's the struggle. If you think about -1 and 1, square both of them, you're saying it's only 1? It's in between 1 and 1, so it's only 1? No, it's between 0 and 1. It's all the positive values. However, if I put 0 over 2 to the n, and if I put 1 over 2 to the n, kiddos, what's the limit as I go to infinity of this guy?
0.
Yeah. How about as I go to infinity of this guy?
0.
So then what is this squeeze to be?
0.
There you go. We can illustrate that way.
L'Hopital.
Ooh! Now our book decides to cover L'Hopital. Which is interesting if you think about it, because our book chooses sequences. Think about last year. Think about last year. What if I had chosen to review sequences before we ever did L'Hopital? Now, number one, I hopefully would have been working towards sequences in series, which we didn't need in AB, which is why I didn't do it. Spell it La Hospital, that's how the AP is going to, but pronounce it L'Hopital, please. Frenchies will appreciate it. I try. No kiddos. Quick dilemma. All those indeterminate forms, we haven't really had to struggle with a lot of them. Last year, did you see some tricky ones? Yeah, a few. This year in section 2, did you really deal with tricky limits? With tricky limits? Probably not. So even though some of you guys use L'Hopitals, it wasn't exactly necessary at that point when we were reviewing basic limits. However, 9.2 is definitely going to challenge you as far as application because, remember, even though you're not making an endeavor card for L'Hopitals, you've already learned it. It was made an AB topic starting, so last year or the year before? Okay. Oh yeah, because this is the new rewriting.
Yeah.
Or the new way of questioning. L'Hopitals was just introduced to AB last year. I had covered it a couple years before that just because it could have been helpful on some of the algebraic manipulation ones. Yes, it was nice on section 2, just wasn't needed. L'Hopitals, you guys state it for me, it's an endeavor card, it's a forever card. If the limit as x approaches c of f of x over g of x produces, well I should just say, if the limit as x approaches c of a function produces what? An indeterminate. Then the limit as x approaches c of f of x over g of x equals? You make that mistake and I take off points. And I did. The limit as x approaches c of
X prime of x over g prime.
pause. The entire rule only works for which two forms?
0 over 0.
0 over 0 and infinity over infinity. So struggle. What do we do if we have an indeterminate and we can't use L'Hopital's because we don't have a top and a bottom? We make it.
Yep. Minus 2.
We creatively transform it. We multiply by 1 creatively. We simplify, we get common denominators, we play around with it, right? So remember, out of all these indeterminate forms, these two are the easiest. You recognize them? Good, they're the easy ones. What about those? Could you logically probably convince someone in younger maths that that's equal to 0?
Yes.
Is it right? No. Could you probably make someone believe that's 1?
Mm-hmm.
Or 0?
Yes.
Could probably make them believe it, but then would you be right?
No.
No, either one could be wrong sometimes. How about 1 to the infinity? Of course that's 1.
Yeah.
You could make someone believe that,
How is
but it's indeterminate. How about infinity to 0? Of course that's 1. It's indeterminate. Struggle, right? We're going to have to get all of those forms into the first two, but pause and go back for a second to these nice little endeavor cards. But, how about 1/2 to the infinity? It's not 1 to the infinity, it's 1/2 to the infinity. That's 0. How about 1/3 to the infinity? How about negative 2/5 to the infinity? We can say that's 0. That's okay. How about 2 to the 1 over infinity?
0.
Yeah. How about 3 to the 1? Okay, so there are some statements we can make, but that's not indeterminate forms. Indeterminate forms are going to look like something that you could make a jump in, and you're not going to be able to do it correctly. You guys don't need that. That was from last year. We already have that. It was already the card you wrote down, already the card you multiplied, so we're not making endeavor. When is L'Hopital's required? When there's no algebraic manipulation possible. Does that make sense? At least none at the basic level that we're able to. Alright, okay, finish 9-1. Here comes some other questions that you might have. Keep that endeavor card close and write it down. And 9-2, we'll see how much of a L'Hopital master you really are.
Honesty.
I thought you were. Bye, guys.
The thing is, we asked that and
Lucy. Just go back to the ESD room if you get done early.
Okay, which math do you really want to
Thank you for letting me know.
One day I'm gonna get back to the line.